Good morning. So today's lesson, I hope is a fairly easy one. We're talking about the role of the operating system to do with managing peripherals, that means stuff that you plug into your computer, and users, that means the users who log into your computer. So really essential in terms of providing functionality and security for both. So we need to make sure we define peripheral, and I've said it's a piece of hardware that you plug into a computer. Whenever you plug something in, usually behind the scenes from your perspective, but the operating system needs to be able to communicate with that peripheral, and that requires drivers. So if you've got a gaming PC, you'll know that your frame rate can be massively increased or decreased depending on the quality of your driver. If you have a new driver, you can get a higher frame rate because that software allows your game to communicate with the operating system, which communicates with the hardware to get a better frame rate out of it. We need to understand two major types of user interface. Interface means the thing between. So the interface between you and your computer is a screen and a mouse and a keyboard, and it's a graphical user interface. We'll talk about that and the alternatives. In terms of user management, we need to define access control and the controls that you can have to limit bad people or to provide access to the right people. And then alongside access control is authentication. And providing certain rights. So let's have a look. We've already said, so let's put things in context. We did process management, as in scheduling, like round robin or shortest job first, all of that kind of stuff. It's about splitting up your CPU time between all of the applications, the processes. We've talked about file management already, as in we order files into blocks, and each block can have multiple numbers of bytes, and you can organize the files into folders, directories, that kind of thing. Today we're talking about user management and peripheral management. So we talked about scheduling last time, and we touched on virtual memory, which is where we know we can only run stuff from RAM. You can't run programs from your hard disk. You've got to get it from your hard disk first and plop it into RAM. But RAM has a limited capacity. So one role of the operating system is to share out that RAM by saying, I don't need this anymore, shove it back into the slow stuff, the virtual memory, the hard disk space, to free up some RAM so that I can load something else. All right, so that's the context. These are your peripherals. Periphery means on the edge. So you sometimes hear politicians talking about people on the periphery of society. You know, the homeless people or the refugees. They matter, but they're on the periphery, on the edge. So on the edge of a computer is a peripheral. It's something that is plugged in additional hardware. The computer might well run without it, but it provides an additional functionality. Sometimes it's inside the case. This is a network card. Sometimes it's outside the case, and there's all sorts of different types. Different devices perform the same thing. Oh, help, I mean a blank screen. So this is a graphics card. You'll have different types of graphics cards. But for your game's perspective, you don't want to rewrite your whole game so that it runs on an NVIDIA graphics card compared to an Intel graphics card compared to like an AMD one. You just want to write your game once. The operating system's job is to have a different driver, and that driver has the code for your specific piece of hardware. So that's the role of a driver. Without the right driver, your operating system isn't going to be able to use your peripheral, which means that you need to keep it up to date, sometimes because of security vulnerabilities, as in there was a problem with some fancy gaming mice that meant anybody could just plug in a gaming mice and get administrator control over any computer, which is one of the reasons why the technicians don't allow you to bring your own mice and keyboards into school. Or it could be to do with performance, so you highly optimize it. Remember, these drivers are likely to be optimized to reduce the amount of memory and to increase the speed. So we've just discussed and agreed that drivers are going to be written in a low-level programming language like C or assembly if we need to get absolutely every bit of performance out of them. You would never write a device driver in Python, but you might interface with a device driver with Python. So, yeah, know all of that already. User interface, the UI. You've got two types of user interface, a graphical user interface, mouse, keyboard, menus, all of that, or a command line interface, like Linux, where you type out your controls. Beginners prefer the graphical user interface because you don't have to memorize all the commands. But personally, I find them really slow. I find the mouse inaccurate. I'm a much faster typer than I am a mouse shover. I prefer typing stuff. And there are others as well, but these are the main two you need to know about for your GCSE. This is what a graphical user interface looks like. It's not just Windows. It could be something like Android or iOS or Mac OS. Most GUIs, graphical user interfaces, use a window, icon, menu, and pointer format, as in each program is in a window, each program has an icon, each program has a menu, and you use a pointer to use it. But that's changing really, because you touch the screen, and if you've got, like most touch screen devices are 10-point touch, and the whole of the Windows design system had to change, because Windows was initially designed to have one mouse and only one mouse. But people have 10 fingers and you can touch a touch screen in 10 different places. So you can't control a touch device in exactly the same way. It's just a different paradigm, a different way of doing things. You might be less familiar with these, but you'll recognize them. You type out a command. They're really good for scripting and automating. And then we talk about user control. Now, authentication and access control, you probably think they're the same, but they're not. Authentication means, can you log in or not? Yes or no. Access control isn't just black and white. It's saying certain people can do more than other people. As in, administrators can do everything. Teachers can do a bit more than students, but students have a fairly locked down account. So it means you put users into groups and you assign certain privileges to certain people. So we've said this already. Authentication can be to do with the username and passwords. You might have multi-factor authentication, as in you put your password in and then it pings you a little PIN code, and you've got to put the PIN code in as well from your mobile phone, or it could be biometrics. And I think that's enough to get us started. I'm sure I had, there it is. So for now, you just got to say, are all of these devices input peripherals, output peripherals, or both? And I'll pause you when we've had some time to do this. Okay, so most people have finished activity 1. We're now talking about the advantages, the features, disadvantages, and a picture of GUIs versus CLI. So graphical user interface is a GUI. Remember, we described the WIMP functionality. So usually in terms of W, window, and then I, icons, and then M, menus, and then P for a pointer. So you move your mouse pointer around, you click or you tap on stuff to be able to select and control things. That's different to a command line interface where you type on a keyboard. And there are different advantages and disadvantages. They're aimed for different people. GUIs are great for beginners. They're harder to break. It's all very visual. It can look very pretty. It's artistic. It's creative. CLI, it's great for scripting. You can chain commands together, automate, simplify, speed up. If you're good at typing, you can do it much faster. It's more accurate. The output is something that you can then collect and process. It's less processor intensive. If you see Windows 11 on a moderately spec'd computer, it can sometimes slow to a crawl just because it's rendering Windows. Compare that to something really simple on a command line interface. But there are advantages and disadvantages for both. And then image just means take a screenshot or grab a screenshot from the internet. So for activity 3, we just need to read through the type of activity and think about permissions. So it's just going to be a simple yes or no for each person. For example, access the laser printer. Well, some schools would say no students are allowed to print, otherwise they're just going to reel off loads of stuff. In this school, you are allowed to print, but only if you log in with your own username and password. In my previous school, any student could print, and there was just a big box of wasted paper from students who send a 100-page document to print and then forget all about it. So I'm going to say no here. Should a teacher be able to print? Well, yes. Should an IT technician be able to print? Well, to be honest, I reckon an IT technician is likely to be able to do everything. They're going to be an administrator with access to everything. Just think carefully. This is not authentication. This is access control. Authentication means, has the user provided the proof that they are who they say they are, as in a password or biometrics. Access control means, okay, now that they're logged in, what are they allowed to do? They both go hand in hand. So I'm just going to explain what to do for the extension for this. I'd like to have some experience investigating how to do graphical user interfaces. So the easiest way to do that is use a module called tkinter, which comes with Python. So I just searched for tkinter tutorial, and there's loads out there. And basically, I just want you to experiment and play around with it. There's loads that you can do. I don't particularly like tkinter, but it's all right to start off with. So I'll put the tutorial on one side, I'll put Thonny on the other. Eek. Where's Thonny gone? I'll put it on a different screen, sorry. Plop it over here, there you go. On some of the computers I've been messing around using Python on a different device, so if you have error messages like I've got on here, just make sure it says use the same interpreter that Thonny uses, and we should be fine. So let's see, can we import tkinter? Will it work? I'll need to save it. Let's save it as, I don't want to save it over somebody else's work. Yeah, so we don't have any errors. I don't think you've seen this syntax before as tk. It's just for laziness, really. Instead of saying tkinter dot, you can now do tk dot. So we've got something like window equals tk.tk, a little bit like turtle.turtle. Won't explain how it works. I'm just going to call it win. We're creating a window. Will we be able to see anything? Yeah, there we go. We've just made a graphical user interface program in 2 lines of Python code. I'm not going to show you how to do anything else, but you can follow the examples to put labels in, to put buttons in, to have events that make stuff work. Have an experiment, screenshot your code, screenshot the results so I can see the user interface, and pop that at the very end of your Word document before you submit if you want to do the extension.